So today we are going to be finishing up chapter 4 with solution stoichiometry. So all this means is we are going to apply our solution calculations, molarity, titration to our stoichiometry calculations. So since they're mole-based, you already should have actually foreseen this coming, that if we know the moles of one of our reactants, we can figure out the moles and then grams or even the solution concentration of our products too. So converting between molarity of something to molarity of something else, to volume of something else, to moles of something else. So from the molarity of our reactant, we can figure out the moles of our reactant. If we have two reactants, then we can figure out which one is the limiting reactant. Once we have that identified, we can figure out the moles of the product using the balanced equation. And then if we know the moles of the product, we could figure out the grams of the product, the molarity of the product, or even the volume of the product too. And we could calculate this with just multiple parentheses, so a nice long dimensional analysis problem, or we could do it as separate steps. Both are perfectly correct, and it will be up to you on what style you prefer. So we've got an example here. We have how many moles of water will form when 25 milliliters of 0.1 molar calcium hydroxide solution is completely neutralized by excess HNO3. First off, when you see the word excess, that should make your heart happy because you know you don't have to worry about limiting reactant problem. So we have excess HNO3, so all of my products will be determined by the amount of moles of calcium hydroxide. So we don't have to worry about limiting reactant. So first thing we are going to do is we are going to write out the equation for the reaction. So we are reacting calcium hydroxide, which hopefully you recognize as being a strong base. That is reacting with nitric acid. Hopefully you recognize nitric acid as being a strong acid. Since we have an acid and a base, we have a neutralization reaction. So we are making water, which they actually already told us that we are making water, and an ionic salt. So the water is formed from the hydroxide ion from the base, hydrogen ion from the acid combining to make the water. That leaves behind the calcium ion and the nitrate ion. Calcium makes a +2 charge, nitrate makes a -1 charge. So the formula of my salt would be CaNO3, 2, and that would be aqueous because nitrates are always soluble, no exception. So this would make an aqueous solution, and the calcium and the nitrate ions would separate in solution if we needed to know that. All right, then we need to balance out our equation. So when we balance our equation, we have 2 nitrates. So therefore, we would need 2 nitrates there. And then we would need 2 waters. Then we would be all balanced. Okay, so basically, if you know moles in chemistry, you know everything else. So we take the original molarity, so the 0.1 molar solution of calcium hydroxide. Remember, molarity is moles over liters. So I can solve for moles because I have 25 milliliters. So that would be 0.025 liters. So remember the molarity equation, it has to be liters, so we have to convert. All right, so we do our math, and that would give us, sorry, that decimal keeps going away, 0.0025 moles of calcium hydroxide. All right, once we know moles of calcium hydroxide, we know moles of both of our reactants. So calcium hydroxide to water are in a 1:2 ratio. So if I have 0.0025 moles of calcium hydroxide, I would have 0.0050 moles of water. Now we should not just be plopping numbers down. If we are not doing this through dimensional analysis, we should explain it. So because they are in a 1-to-2 mole ratio. You could have also done dimensional analysis to show that. Now, once we have moles of water, we could find grams of water too, but the question actually just asked us for moles of water. So other than significant figures, we are done. We should have 3 significant figures. So if we add that in there, we are good. Okay. Next example, how many grams of water are formed when 50 milliliters of barium hydroxide react with 105 milliliters of 1 molar hydrochloric acid? We're not as lucky as we were last time. We have the amounts of both reactants, so we are going to have to do a limiting reactant problem. But before we get to that, first thing we have to do is write out our reaction. So we have barium hydroxide. So that is another strong acid. And that would be an aqueous solution. That is reacting with hydrochloric acid, HCl. That would also be an aqueous solution. All right, since again we have an acid and a base, we are doing a neutralization reaction. So we are making water and an ionic salt. Our ionic salt in this case is going to be barium chloride. Barium makes a +2 charge. Chloride makes a -1 charge, so we get BaCl2. That is soluble, so that would be aqueous. Chlorides are always going to be soluble unless they are with silver, the silver ion, the lead +2 ion, or the dimercury ion. All right, when we write our reaction, we also obviously have to balance it. So we have 2 chlorides, so we would need a 2 in front of the HCl, and then we would also need a 2 in front of the water. Next step, turn everything that we were given into moles so that we can find our limiting reactant. So we will take the barium hydroxide and turn that into moles. So we have 0.75 molar. We have to find moles. My volume is 50 milliliters. I have to turn that into liters because molarity has to be liters. So 0.50 liters. And that gives me my moles. So we just multiply those two. Probably do this in my head also. Okay, 0.0375 moles of barium hydroxide. We really want to label because since we are getting multiple things happening, we want to make sure that we know what the different numbers refer to. All right, we're going to do the same thing now, except we have to do it with hydrochloric acid. So with hydrochloric acid, we have a 1 molar solution. The volume is 105 milliliters, so 0.105 liters. So then that would give me 0.105 moles of hydrochloric acid are present. All right, so barium hydroxide to hydrochloric acid are in a 1-to-2 ratio. So looking at these two amounts, I start to think that my limiting is probably barium hydroxide because I have way less barium hydroxide, but I need to take a second to think about it. If I use the 0.0375 moles of barium hydroxide, I would need double that for hydrochloric acid. I have over 0.1 for hydrochloric acid, so that tells me hydrochloric acid is going to be present in excess, and barium hydroxide is going to be my limiting reactant. But I should write that out to be thorough. So then I could say if 0.0375 moles of barium hydroxide react that would require double that. I would need 0.075 moles of HCl. I have 0.105 moles of HCl. So I have way more HCl than I need. So barium hydroxide is my limiting reactant and what the rest of my reaction is going to be based upon. All right, so now that I have figured that out, I can finally get to what my question actually was asking, was how many grams of water will be produced. So let's erase this so that we make a little bit more room there. Okay, so I'm going to take my 0.375 moles of the barium hydroxide that are present. And I just need to turn that into moles of water and then grams of water. So I use the mole ratio to turn that into moles of water, moles of barium hydroxide on the bottom. That has a 1 in front of it in the balanced equation. So 1 down there. Water has a 2 in front of it in the balanced equation. So a 2 up here. So the 1 mole of barium hydroxide produces 2 moles of water. Okay, now I have moles of water. From moles of water, I just do 1 mole of water is equal to 18.016 grams, and that will give me my answer. 1.35 grams of water, but I only want 2 significant figures, so 1.4 grams of water. All right, titration. So titration, you might remember from reagents, is the process of when we add a known amount of either our acid or base to the other one to do a neutralization reaction.